All right, what's up, everybody? So today we want to start to look at finding some percentiles with a normal distribution using our calculator. Going old school today, going whiteboard, just because. So we're still working with the normal model, right? And so far, we know that if something's normally distributed, like IQs we used in the last video, we know that about 68% of data falls within one standard deviation, 95% of data within two standard deviations, and almost all of the data, right? 99.7% of the data within three standard deviations. So we've used this information to answer questions like, what's the probability someone's IQ is above 115, right? And kind of added these, or maybe between 70 and 115, right? And so on and so forth. So we've used this rule. We've just, we've figured out that there's each of these and 13, 5, and so on, right? And we've used those percentages to find some normal percentiles or probabilities. But today what we want to start to look at is what happens if I ask you, what's the probability that some person's IQ is over 117, right? What do we do if we want to find this, right? When we're not exactly 1, 2, or 3 standard deviations above the mean. I challenge you to pause the video and kind of think about that right now. Try to come up with your own idea, your own solution as to how you might approach that. Ultimately, when we have a question like this, we're going to have a couple options. So, a real old tool. So if we're not exactly 1, 2, or 3 standard deviations away from the mean, how can we find our percent or our probability? So we've got two options. One option, kind of the more old school approach, before I guess graphing calculators and technology, is to use z-scores and a z-table. And so we'll look at that. We'll have a separate video for that. Another option is to use Normalcdf on our calculator, and that's what we're going to focus on today. In general, for any of these, if you like a step-by-step approach, you're going to like this. So for any of these types of problems, right, we're going to draw a picture and shade. We'll talk about why we want to do that. This maybe we're going to show a z-score. So that really probably just depends on who your teacher is, but we'll look at, how you could use a z-score and why that might be valuable. We're going to show Normalcdf, right, the calculator inputs that we have, and make sure we label all the information. This z-table we're not going to focus on right now. That's going to connect to this red method. We'll use a separate video for that. And then, identify your answer clearly. So to get kind of ahead and get into the big picture a little bit, we're going to learn how to use two things, right? So we're going to learn how to use Normalcdf on our calculator, and we're going to learn how to use inverse norm on our calculator. So inverse norm, that's going to happen in the future. But when we get, start to look at all this stuff mixed together, one of the challenges is to decide which calculator function I'm supposed to use. So in general, if I'm given some data value and I want to look at the percent or probability of being above or below or between some data values, and I want to get a percent or a probability as my answer, that's when I use Normalcdf. So for example, right, we're given what's the probability someone has an IQ over 122, right? That would be 100, 115, so maybe 122 is right here. All right, so if we want to start with a data value and we want to find the area under the curve, the percent or probability, Normalcdf. Whereas if we're going to use inverse norm, that's when we're starting with the percent or probability. We want to go to a data value. So maybe we want to try to figure out which IQ cuts off the 80th percentile. So we want to figure out which IQ would go right here, right? So that 80% of the data is to the left of it. So looking ahead, big picture, that's how we kind of distinguish between Normalcdf and inverse norm. To get to these things on our calculator, you're going to, with a TI, Casio, we can talk separate, or, obviously Google it. I'm going to press second vars, right above vars, this distr, to go to my distribution menu. And we can see right here, there's Normalpdf, Normalcdf. We're never going to need to use Normalpdf. I believe that's used for graphing. I don't even know. I've taught stats for a long time. Maybe that's embarrassing. I don't know. And then we're going to use inverse norm. And all this T stuff will come in the future, and this chi-squared stuff down here, that's a glimpse into your future in the second semester of stats. But for now, we care about numbers 2 and 3. So we'll look at what we have to enter in a minute. So here we go. I'll jump into my old school PowerPoint here. So here's our context. Pause the video and check that out. We got a study investigated about 3,000 meals from Chipotle restaurants using Grubhub. So they looked at the sodium content, which is measured in milligrams, and the distribution of the sodium contents is a normal model. So that's key information. So as you're reading the question, right, another thing to think about is how do I even get to the point where I might be using normal CDF or inverse norm? And of course, those have to be related to a normal model. Then we've got mean of 2,000, standard deviation of 500. So for sodium contents in milligrams, we know we have a normal model with a mean of 2,000 and a standard deviation of 500. So here we go. First example. We're going to figure out what percent of Chipotle meals have a sodium content above 900 milligrams. So step one, draw a picture. Start, I can label my mean. My mean would be 2,000. Now, when I draw this picture, I want to shade the area. I want like a visual representation of the question. So I want to shade the area for sodium contents above 900 milligrams. So I don't necessarily need to label all three standard deviations above and below, right? I just need to kind of figure out where 900 is. So one standard deviation below would be 1,500, right? Two standard deviations below would be 1,000. So 900 is, around here. And I want to mark that value and shade, right? I'm trying to represent the question. Question's asking for the percent of Chipotle meals with sodium content above 900. So I want to shade right above 900. So that is step one. The reason we want to draw a picture is because on our exam, we have a few things we have to do. We have to identify the bounds. So by drawing this picture, we're visually identifying the bounds. This is our lower bound, and it's showing that we're shading to the right. Another thing is we want to define the model. And so by drawing this picture, we're showing we're talking about our bell curve, our normal model, and we're clearly identifying the mean and the standard deviation. So it counts as like implied labeling the standard deviation, as long as you label at least one standard deviation above or below. So that's why we're doing this sketch. Another way to define the model would be to give this notation we used above, right? We're literally defining the model here, normal, mean, standard deviation. What am I doing? I'm thinking of IQs. All right, so kind of either or both, right? We want to check all the boxes. So our question is asking us to find how big is this region? So we should know some things, like for instance, our answer has to be bigger than 50%, right? We've shaded more than half of this picture. And we might even remember that in here is 34%. And in here is 13.5%. So from the empirical rule, we should, be able to recognize that our answer has to be a little bit bigger than 97.5%. Now for a free response, that's not going to help us get the final answer. But if this is a multiple choice, then, right, like we probably can significantly narrow down our options. Be a little bit bigger than 0.975, right? Because we're looking at 0.975 would be this part, and this part. We still have this tiny little red sliver to add in. So, right, we can use the empirical rule to really, really narrow down our options. But to get that exact probability, we're going to have to use our calculator. And so on our calculator, we're going to use Normalcdf. So we need to define that language on our paper. And in Normalcdf, we have to define the lower bound, the upper bound, the mean, and the standard deviation. Now, the way this pops up on your calculator, right? You might have a calculator model that literally the screen looks like this. So we need to define that we're using Normalcdf. We also have to label all of the information, right? So you can just copy down what shows up on your screen and what we're going to fill in. Some of us might have a calculator where it just pops up and says Normalcdf. And so we have to then know what to type in, and we have to label this. So we have to know we're going to enter the lower bound, the upper bound, the mean, and the standard deviation. Now, if you have to write this yourself and you're not copying this off your screen, maybe you just use words here. And the reason is if you wrote like X bar and SX, that's incorrect notation, right? So then we could get, we can get hit for some points there. So we either need the correct notation, mu and sigma, or if you're questionable about the notation, just write those words, right? That's a good backup plan. So far, right, we got a lot of stuff. Now we need to think about what each of these represent. So the lower bound is essentially the left side of the shaded region. So our lower bound, that's that black 900 right here, right? That's the left side of the area that we shaded that we're trying to find, the percent of Chipotle meals with sodium over 900. Our upper bound is the right of the shaded region. Now remember, this curve's like an asymptote. This extends to the right forever. So the lower bound is the left of the shaded region. The upper bound is how far right this goes. And we flash back to our domain and range days. And so this would go to the right to infinity. And then our mean and standard deviation, that's easy. That's our 2,500, right? So this blue box and this picture over here, right, the red and the blue, that's our work. We need the shaded model. The model needs to have the shape, at least one standard deviation above or below, the number in the question, and right, the correct direction, shading left, right, or between. And here we need to have all our labels. So now we go to our calculator. So I'm going to press second vars to go to my distribution menu. Make sure I choose Normalcdf. My lower bound was 900. Now my upper bound, right? Our upper bound is infinity, but there's no infinity button on the calculator. So we need to try to represent a giant number. So we hit 9 a lot, right? We're trying to just represent infinity. There'll be an infinity button. And now our mean and standard deviation. We hit paste. We can see it pop up on the screen, just as I had written it down here. Right, 900, comma 9999999. You can, when you're showing your work, write an infinity symbol, by the way, that's fine. Right, and then the mean and stuff. And then boom, there's our answer. As expected, it's a little bigger than 97.5%. So our final answer over here, 0.986, but it did ask for a percent in the question. So 98.6%. So pretty much all the Chipotle meals with sodium content above 900 milligrams. One down, 2 to go. Next up, so we got some background information here, but ultimately this tells us the average content for the beta restaurants, average sodium content is 1256 milligrams. Some others is 1500. We want to know what percent of Chipotle meals have between 1,256 and 1,500 milligrams of sodium. So step one, you got to draw that picture. Of course, you should pause the video and try to draw this picture yourself. So we got 2,000 here. This is our 1,500. This would be 1,000. So we want between 1,256. 1,250 would be right in the middle. So 1,256 and 1,500. We could use the empirical rule to try to narrow down our options here. For instance, we know the answer is less than 50%. We know the answer is less than 13.5%. 5% would be between my fingers here. To get the exact value, we're going to jump right to Normalcdf. This time I'll fill in the information in a row, just for no real reason. Lower, upper, mu, sigma. We know these are 2,500. And the between questions might be the easiest to recognize, the lower and upper, because the lower, right, is just the left side of the shaded region. And so we can see up here, the left end of this is 1,256. And then the upper bound is the right side of the shaded region. And so that's our 1,500. As you get comfortable, move through these. Normalcdf, 1,256, 1,500. That's not what that says. That's left there from before. 9.03%. 0.0903 or 9.03%. Or we could say the probability that a Chipotle meal has between 1,256 and 1,500 milligrams of sodium is 0.0903 or 9.03%. So on the exam, these are considered probability questions. Last one. So here we've got a healthy sodium intake considered less than 2,300 milligrams of sodium per day. I Googled it. So we want to know the probability that a Chipotle meal sodium content is less than 2,300. You do it. Right? Pause the video. Wait, I don't know. I forgot how to speak English. You try. You got 2,000 in the middle. That's 2,500. We want less than 2,300. So 2,300 is right here. We're going to shade to the left. So what's that? Think, how do you know that the answer should be less than 84%? Right? It should be. It's got to be less than 84%. How do you know that? There's a couple ways you can think about it. Let's find out if it really is, if I know what I'm talking about. So our lower, upper, started drawing a mu, sigma. You're thinking there, the lower. So this time, the lower is the left of the shaded region. How far left does this go? It goes left forever, so we could say negative infinity. The right side of our shaded region, that's that 2,300. Normalcdf, negative infinity, so a bunch of 9, 2,300. Yeah, 72.57%. Less than 84 as expected. All right, one last. So z-scores. So we can use z-scores with our normal model. So if we revisit that same question that we just did, right? This was 2,000 in the middle. This is 2,500. We wanted to find the probability that there was less than 2,300 milligrams of sodium in this meal. So we can use z-scores with the normal distribution, right? Like clearly we don't have to because we just answered all of the problems without using z-scores, but we can also use the z-score. So I could calculate the z-score for this 2,300, and that's going to give me 0.6, right? 300 over 500, or 3/5. So I get z equals 0.6. So I could use the z-score and then go to Normalcdf, right? And remember, again, I want to emphasize, we're finding the size of this shaded region, right? This blue area is a visual representation of the answer of what percentage we're trying to find. So we could use Normalcdf, but instead enter z-scores. The lower bound is still negative infinity. This still goes to the left forever. But now for my upper bound, if I want, I can use this z-score of 0.6. And if I do that, now when we enter the mean and standard deviation, we have to keep in mind that these values are all in terms of z-scores. So what would we have to enter for the mean and standard deviation for z-scores? 0, 1. Yep, for z-scores, the mean is 0, standard deviation is 1. Right, so this is just another way, right? Or if we label everything in terms of sodium contents in milligrams, then these last three numbers are 2,300, 2,000, and 500. Right? Just a different way to identify the bounds, right? We can label them in terms of sodium or z-scores. So just something to be aware of, just in case there's a multiple choice sometime and maybe you're only given a z-score, so you have to enter that in your calculator. We'll play with this stuff some more, keep practicing, look at some inverse norm, look at some z tables coming soon.